Hello students, I welcome you all to the online video lecture on course Heat Transfer. Today we are going to discuss the numericals on the application of lumped parameter analysis in the temperature measuring instruments. Okay, so let's read the problem carefully. A thermocouple junction is in the form of 8 mm diameter sphere. The properties of material are C, specific heat 420 joules per kg degree centigrades. The density rho equals to 8000 kg per meter cube. Thermal conductivity K equals to 40 watt per meter degree centigrades. And heat transfer coefficient H equals to 40 watt per meter square degree centigrades. The junction is initially at 40 degrees centigrades and inserted in stream of hot air at 300 degrees centigrades. Find first bit time constant of the thermocouple. The second bit, the thermocouple is taken out from hot air after 10 seconds and kept in still air at 30 degrees centigrades. Assuming the heat transfer coefficient in air as 10 watt per meter square degree centigrades, find the temperature attained by the junction 20 seconds after removal from hot air. This is a very important problem. Let's solve this problem systematically. Now, initially, we have to write the given data. The first one is diameter of the sphere. So we have to assume the thermocouple junction as a spherical member. So the diameter of sphere D equals to 8 mm or 0.008 meters. The radius equals to diameter by 2, that is 0.004 meters. C is 420, rho is 8000, K is 40, and H is 40 watt per meter square degree centigrades. Now the initial temperature of junction is 40 degrees centigrades. Initial temperature of the junction is 40 degrees centigrade, that is Ti. So it is inserted in the stream of hot air which is at 300 degrees centigrades. So this is Ti 40 degrees centigrades and Ta is 300 degrees centigrades. In these conditions, first one we have to find out the time constant. So let us focus on the first bit, which is very easy, how to find out the time constant of the thermocouple. So we know the time constant or the thermal time constant of thermocouple is a T star, which is given by rho Vc by HAS. I repeat, T star or tau star, tau star is rho Vc divided by HAS. So we know V by AS. For spherical member, V by AS is R by 3 because V by AS is nothing but characteristic length. So the characteristic length for spherical member is R by 3. So R by 3 into rho C divided by 3H as it is. So substitute all the values, you will get 112 seconds. 112 seconds. Okay. Now, in that second bit, he is asking us to calculate the thermocouple is taken out from the hot air after 10 seconds. So initially, the thermocouple is at 40 degrees centigrades and suddenly it is exposed to the stream of hot air which is at 300 degrees centigrades for the period of 10 seconds. Okay, for the period of 10 seconds. Now, the temperature attained by the junction, that is T, after 10 seconds in hot air which is at 300 degrees centigrades, and heat transfer coefficient is given. So first we have to find out the Biot number and check whether the lumped parameter analysis is applicable or not. So Biot number is HLC by K, LC is R by 3, you know the radius, you know the heat transfer coefficient, you know the thermal conductivity K, substitute and get the value of Biot number, that is 1.33 into 10 to the power minus 3. So the Biot number is less than 0.1, so lumped parameter approach is applicable. Okay, Now use this formula, T minus Ta divided by Ti minus Ta equals to e to the power tau divided by tau star, where tau star is rho Vc divided by HAS. Okay, so tau star is already we have calculated. So tau star already we have calculated, that is 112 seconds. Now substitute, see tau equals to 10 because the thermocouple is in the hot air atmosphere, which is in 300 degrees centigrade, which is at 300 degrees centigrade for the period of 10 seconds. So this 10 seconds will be tau, and tau star is the time constant, that is 112 seconds. Now here T, the only unknown is T. So T equals to 62.2 degrees centigrade. 62.2 degrees centigrade. Now what he is asking, find the temperature attained by the junction 20 seconds after removal from hot air. After removal from hot air. So please try to understand this carefully. The thermocouple is taken out from hot air after 10 seconds and kept in still air, which is at 30 degrees centigrade. So let me draw the diagram first. Let me draw the diagram to understand it carefully. Let me draw the diagram. So this is the hot air atmosphere. Let me take this as hot air atmosphere, which is at 300 degrees centigrade, which is at 300 degrees centigrade. Now initially the thermocouple junction, which is at initially 40 degrees centigrade, which is initially at 40 degrees centigrade, is suddenly exposed to the hot air, which is at 300 degrees centigrade for the period of 10 seconds. For the period of 10 seconds. I repeat, initially the thermocouple junction, which is initially at 40 degrees centigrade, is suddenly exposed to the air, hot air, which is at 300 degrees centigrade for the period of 10 seconds. For the period of 10 seconds. After this, the thermocouple junction, is suddenly exposed to the air stream, which is at 30 degrees centigrade, which is at 30 degrees centigrade. Now after 10 seconds it is removed. After 10 seconds it is removed, and suddenly it is exposed to the air, which is at 30 degrees centigrade for the period of 20 seconds. For the period of 20 seconds. Now what he is asking, after 20 seconds, what is the temperature attained by the thermocouple junction? After 20 seconds, what will be the temperature attained by the thermocouple? Okay, so first we have to calculate here. First we have to calculate what is the temperature attained by thermocouple junction when it is kept for 10 seconds in the air, which is at 300 degrees centigrade. So that will become T. So after this calculation, after calculating the value of T, now we have to go for this. Now whatever the value of T, which is calculated for the first environment, that which is at 300 degrees centigrade, that will become Ti. That will become Ti for the second condition. For the second condition. So take this T as Ti for second condition. The surrounding temperature 30 degree Ta is known. Okay. Now the time is also known, that is 20 seconds. Now get the value of the temperature after 20 seconds. Okay. So this is the main approach of the problem. This is the main approach of the problem. Okay. So if you practice it thoroughly, then the things will become easy. Don't worry. Now first we have to calculate what is the temperature attained by the thermocouple junction after 10 seconds in the stream of hot air, which is at 300 degrees centigrade. Okay. Okay, already we know the value of T star, tau star. So we got the temperature as 62.2 degrees centigrade. This is a temperature attained by thermocouple after 10 seconds in the stream of 300 degrees centigrade air, hot air. Okay. Now in the continuation of second bit, what he is asking us to calculate the temperature of test junction when it is suddenly removed from hot air and placed in a still air which is at 30 degrees centigrade. So after 20 seconds, what will be the temperature attained by the junction with heat transfer coefficient H equals to 10 watt per meter square degree centigrade. So now this will become Ti. So the temperature in the first case after 10 seconds, that will be considered as Ti for this condition. So Ti is 62.2 degrees centigrade and Ta is ambient air 30 degrees centigrade. And what is the time duration for the cold air for the second case? That is 20 seconds. So again, we have to calculate the value of T star, that is time constant rho Vc divided by HAS. So substitute all the values here. H is different. Okay, so that's why T star will have the different value from the first bit. Okay, so 448 seconds. So T minus Ta divided by Ti minus T equals to e to the power minus tau divided by tau star. So T minus Ta is 30 degrees centigrade and Ti is 62.2 degrees centigrade and Ta is again 30 degrees centigrade. So e to the power minus 20. The time duration is 20 seconds divided by the T star. The time constant is 448 seconds. Substitute and take substitute and get the value of T. Okay, here take exponential e to the power. Okay, now here T equals to 60.79 degrees centigrade. So this is the final answer. What does it represent? So after 20 seconds, the temperature attained by the test junction in the stream of air which is at 30 degrees centigrade is 60.79 degrees centigrade. This is the final answer of the problem. Okay, so read the problem carefully, practice it thoroughly. First, see and write down the solution as it is. In the next attempt, without seeing the solution, just try to get this final answer. And further, if you find anywhere any difficulty, any confusion as far as the concept is concerned, so please put your comments in the comment box, and please don't forget to subscribe the channel and press the bell icon. Whenever I put the new video on the YouTube, you will get the notification instantly. Okay, so stay safe, stay at home. Thank you and have a nice day.